Hi all, welcome to video 2 of DataBricks playlist. So in first video we have seen what is the need of learning DataBricks, right? And in this video I'll explain you what is DataBricks. So basically in this video I'm not going to tell you only the definition of DataBricks and then we are going to move ahead, okay? No, that is not the thing. This is going to be a little lengthy video, and I would like to tell you first. I would say two, three. I think 3 to 4 videos would be theoretical, because before we go into practical things, it's very important to understand the conceptual things, right? So that's the reason I am making the detailed videos on theories first, okay, and then practicals also are going to be very detailed, right? So in first video I was able to convince you a little why you need to learn Databricks, and from this video I think that convincing will also go to higher level, because I'm going to explain you what is Databricks basically and what are use cases we can achieve using Databricks, okay. Now, I think in last video we have seen the basic definition of Databricks. Okay. I'm not sure if I written. Yeah, see, Apache Spark design optimized to work on cloud. So I think what we have seen is the basic definition. Databricks is nothing but the Apache Spark. Sorry, Apache Spark designed and optimized to work on cloud. Right. Now we will learn about the official definition. Okay, what is official definition of Databricks? This definition is correct. It's not right. It's not the wrong definition, but this is one part of the definition. Okay, so now official definition is basically it says Databricks is unified is unified platform. Okay, platform for building. Okay, deploying building deploying, sharing, and maintaining, building, deploying, sharing, and it is maintaining enterprise grade data. Okay, enterprise grade data analytics. Okay, analytics and AI solutions also, and AI solutions at scale. Right. Let's try to dig into this definition. Basically it is saying Databricks is a unified platform. Now first thing, why it is unified platform? Okay, why unified? Why Databricks is called unified? Right, I'll tell you that there are, I think, 4 to 5 reasons why Databricks is called unified. The first thing, it is because of lake house availability or architecture, we can call. Okay, now what is lake house? I'll explain you what is lake house in detail in next video, but just for introduction, it is like it contains, I'm just telling you, it contains the best of data lake and data warehouse, right? So all the best properties of data lake and data warehouse it contains. And what are those best properties? The storage and scalability of data lake, and the ACID transactions and data management from data warehouse, right? So it contains the best properties of data lake and data warehouse. And data lakehouse basically supports all types of data, structured, semi-structured, and unstructured data. So we can keep all type of data all type of data in one place in this data lake house. Okay, what is data lake house in details? We'll be having, I think, couple of videos around data lake house, because it's very important to understand what is lake house, right? And also we get acid enforcement. Okay, then I would say schema evolutions, right? And time travel time travel in I would say this lake house architecture, right? How we get that, I'll explain you, okay, in upcoming videos. But Just understand, we have presence of lakehouse architecture in Databricks. We can store all types of data. Okay, we can use the best properties of data lake and data warehouse. Okay, those are like asset enforcement. If we have some change in schema or updates in columns, that also can be achieved, and we can travel back in our data using time travel capability, right? So this is the first reason why Databricks is called unified platform. Second is integrated workflows. Okay, integrated workflows. What this is like, whatever code you are writing in your Databricks, right? That might be pyspark code, SQL code, right? You have availability of scheduling that pipeline in Databricks only. You don't need to move to other tool like data factory is there. I think control M tool is there, or many scheduling tools are there, right? So you don't need to move to any other tool. Databricks has that capability also, right? So running workloads within Databricks is integrated, right? Is available, we can say. Okay, so you create the code in Databricks and run there and then and there only, schedule then and there only, right? Next thing is multi language support, right? So basically in Databricks we have support for multiple language. We can write the code in Databricks using PySpark, we can write using SQL, we can write using Scala, okay, and we can write using R, right? So this multi-language support is present in Databricks. I'm saying about data engineering code, okay, here. And one more thing, there is collaboration. So Databricks can be used by data engineers, okay, it can be used by data analysts, okay, and data scientists as well, and data scientists as well. Why so? It is because we have all types of data in one place. Okay, so data engineer can work on this data to clean this data and do the business aggregation as needed, right? And this data can be used by analysts and data scientists, okay, for their work. Okay, so all data at one place is the best advantage we have using Databricks. And one more thing, next thing, unified governance. The fourth reason why Databricks is called unified tool, right? Unified governance, as in it is governance is centrally managed using Unity catalog. Okay, so basically there is centralized access control, centralized access control, data lineage is available. Okay, data lineage and audit logging, using Unity catalog, also termed as UC, right? You can call it UC also, right? So Unity catalog is a tool, right, integrated with Databricks, using with you can manage the access at centralized level. Data lineage also it captures, and audit logging also it captures, right? This helps to achieve in the security and compliance requirement, right? Security and compliance requirement, security and compliance requirements, right? So this is fourth reason why Databricks is called, I would say, unified platform. Now next and very important thing, right? I think I explained you a little in last video also, the managed infrastructure. So unlike the plain vanilla version of Apache Spark, you don't need to manage the infrastructure, manage the underlying clusters. Okay, Databricks has automated cluster provisioning, okay, scaling of clusters, scaling of clusters, okay, and optimization, right? So cluster optimization is also taken care, right? So we just need to focus on our code, our data. Okay, so I would say user is who are the users? Data engineers, analysts, and data scientists are the users. Okay, or AI engineers also. Users can focus on the logic, okay, and not on infra and DevOps. Okay, you don't need to focus on this, you just focus on your logic, right? The infrastructure is managed by Databricks. How that is managed, we are going to learn in details in this playlist. Okay, now the next thing is uh, AI driven intelligence. Okay, AI driven intelligence. What is meaning of this is, using generative AI in Databricks, we can understand the data semantics, right? We can understand the how data is present, right? What are the semantics of the data, right? Queries are getting suggested, and also we can optimize the performance based on the data stored in data lake house, right? This basically, we can use Gen AI to understand data semantics. Okay, uh, and we can optimize performance. Okay, we can optimize the performance, right? And how this helps? This helps basically to accelerate the development. Okay, accelerate the development work that we are doing and reduce manual efforts. We don't need to analyze the data manually, right? Yes, little manual effort is needed, right? Because human touch is always needed in case of AI, right? So don't think AI will do everything. No, AI is going to help you, right? AI is going to help you in your work, but the logic building and everything you have to take care, right? So help of AI, Gen AI is also available in Databricks, right? And integration. Next thing is integration with clouds. Okay, public clouds. Okay, so Databricks basically has got integration with public clouds. Okay, it is available on all three major clouds. Okay, so that we can use the cloud storage. It integrates with the cloud. We can use that cloud storage and many other services from the cloud. Okay, now why I think why it is important that Databricks is unified. Okay, how it matters, this unified platform thing of Databricks, how it matters is because the traditional platforms, right? For example, if we see the plain vanilla version of Apache Spark, it has separate storage, right? Separate processing, analytics, ML, everything is separate. Okay, we had to, for example, manage the storage separately. Our Apache Spark will do only processing, right? And then analytics will happen on some, let's say, data warehouse which is managed separately, right? If you have to do some AI or ML work, that would be managed separately apart from the Apache Spark, right? In Databricks, everything is present at one place, right? That is the reason Databricks is unified analytics platform. Okay, it is called unified analytics platform for building. Okay, we can build the pipelines there. Deploying, we can deploy the pipelines there. Sharing, we can share the code, okay, or data securely. There is something called delta sharing in Databricks, using which we can securely share the enterprise grade, I would say, data. Okay, uh, and code also. Okay, and we can maintain the solutions also. Okay, and these solutions can be used by AI engineers, ML engineers, or end users also. There is something called, I would say, a SQL warehouse in Databricks, using which end users also can query the data. Okay, and if end users are not, I would say, technical, if they are not aware of SQL, there is something called, I think, Jenny AI BI, which is integrated in Databricks. End user can just put their, I would say, query in natural language, right? And Databricks will get the answers from the data stored in data lake house, right? That is the reason being unified is very much important, right? And as I have told you already, the Databricks integrates with the cloud storage, okay, security of the cloud. These are all three major clouds, okay, and it manages and deploys the cloud infrastructure for us, okay. And I would like to show you one of the image, right? It has been taken from the official documentation of Databricks, okay. You can see unified governance, unified data means data is stored at one place for all the use cases. We can manage the governance, okay. Central governance is there. This data can be used for BI use cases, data warehousing, okay, AI and data science use cases, ETL and real-time analytics also. And orchestration is also available within Databricks. You don't have to go to outside. So Databricks as in easy. Now it is slowly becoming the tool where you can do everything in Databricks, right from raw data ingestion till making your data available for all these use cases. This is what Databricks is moving towards now, right? And that is the reason we are learning Databricks in depth. Okay, fine. Now a few more things I just wanted to. I'm not public, what I can say, I'm not some ambassador of Databricks or something, but this is tool which I love the most. So I am learning with this, I would say, series. I myself also learning deeper into Databricks. Okay, so I wanted to tell you something. Databricks is contributing to open source community also. Okay, Databricks is contributing to open source community as well. Okay, open source community as well, right? How it is contributing to open source community? There are few I would say the projects or tools that are developed by Databricks and they have made it open source, right? The first one from them is Delta Lake. Okay, so this is originally developed by Databricks, but now they have made it open source. I'll tell you what is Delta Lake. In short, basically, for introduction, right? In depth, we are going to learn in upcoming videos, right? So there is something called Delta Lake, okay? Delta sharing. I think I told you the delta sharing sometime before, right? In the definition also. So we can share the data securely, okay, using delta sharing, right? And there is ML flow. Let me just list down first, okay? ML flow. Then fourth one is like Apache Spark. You all know Apache Spark is open source, right? Then next one is structured streaming for streaming use cases. Okay. Then there is something called Red Dash. What is that? I'll let you know. Let me just first list down and Unity catalog, right? Unity catalog. Okay. Now, a short introduction of the Delta Lake, we can call it as a storage layer. Okay, it is storage layer that brings, I would say, acid transactions, acid transactions, and schema enforcement. Okay, to data lakes, right? So, data lakes, as we all know, data lakes are just plain storage, right? There is nothing like acid transactions or schema enforcement in case of data lakes. Delta Lake brings acid transactions and schema enforcements, right? How? Definitely, we are going to learn in upcoming videos in depth, right? What is delta sharing? It is open protocol. It is open protocol for securely, securely sharing live data. This is very important. Live data across platforms and clouds, right? You can share that securely using delta sharing, right? ML flow is open source platform, okay, for managing end to end machine learning life cycle, right? So ML flow is something which we can use within Databricks to manage end-to-end machine learning life cycle. Apache Spark, we all know it is the, I would say, lightning fast distributed compute engine, right? So lightning fast, okay, distributed distributed compute engine. We already have seen that in last video. Structured streaming, it is like the Spark API for processing real time data streams. Okay, Spark API for processing real time data streams. Okay, real time data streams, as in uh, let's say there is some bank transaction that is happening. Okay, there are n number of bank transactions that happens. So if I want to bring that to my data lake house real time, as soon as it happens, I want to bring that to my data lake house. This is Spark API called structured streaming. Okay, we can bring the data and process the data in real time manner. Okay, and it offers fault tolerance also. Okay, it offers fault tolerance also. You will not lose any data. It takes care of fault tolerance as well. And what is red dash? It is data visualization and dashboard tool. Data visualization and dashboard tool. Okay, for for querying and sharing. Let me take it to next line. For querying and sharing insights from the data, right, stored in lakehouse, of course, right. And the last contribution, not the last, I mean one of the seventh contribution to open source community by Databricks is Unity Catalog. Unity Catalog is unified governance solution, right, for managing data access. Okay, and lineage and auditing in Databricks, right? It's not auditing, it's auditing. Okay, so it is centralized tool where we can manage the data access to data, right? Data lineage. Okay, lineage as in the data flow, tracking data flow basically from where to where data is flowing, and auditing, right? So auditing use cases also data, I would say Unity Catalog is helping in, which is helping organizations to I would say follow the compliance regulations also, right. So these are the, I would say, open source projects to which Databricks is contributing. Okay, and we have seen why Databricks is called unified platform, and the official definition we have seen, where we can see we can build the pipelines using Databricks, we can deploy, we can share deploy using basically Databricks jobs. There are Databricks ETL workflows that we can create. These are called as jobs. Okay, sharing the data securely using uh, delta sharing, right. So this is the, I would say, in-depth introduction of Databricks, right? What is Databricks, right? How it is useful? What are the open source communities Databricks is contributing to? Now, I think you are a little bit, convinced that there are a lot of things in Databricks, and we definitely need to spend more time learning Databricks. So I am not in hurry. I'm going to bring all the aspects in front of you. Sit back, relax for first 4 to 5 videos. Those are going to be conceptual, right, and I would say theoretical, but you will enjoy, right. Okay, now the next thing, just to let you know what are common, right, common use cases Databricks is used for. Databricks is used for. Okay, I think 2 3 you have already understood. The first is like I would say enterprise data lake house, right? Enterprise data lake house. Okay, so you can build the enterprise level data lake house using Databricks. Okay, so lake house, I think I have already introduced. It's the modern architecture or modern system, we can say, where best I would say characteristics of data lakes and data warehouse are integrated. Okay, it stores all kinds of data in one place and makes it easy for reporting and analysis, right? And also you can do ML and AI on that data as well, right? The best part is data engineers, data analysts, data scientists, and AI engineers can work from same trusted data, right? Because it contains raw data also and the processed data at one place, as in we'll be having different containers for that data. We'll have separate container for raw data, we'll have separate containers for, let's say, BI use case data, we'll have separate containers for clean data, something like that. But everything is available within Databricks, within Data Lake House. This basically reduces the need for multiple tools. Okay, and you don't need to sync or connect to any other tool for this requirement. Everything, all the data is available within Data Lake House, right? So this is the reason Databricks is very fast, very simple, and more efficient for handling the big data, right? So I would I would like to write here storing data for all use cases, okay, at one place, right? And this supports, you all know, acid transactions, right? Schema enforcement, right? And you would say time travel, right? These are few, I think, important uh, characteristics I'm writing here. There are many more. We will learn them on the journey, right? So this is very first use case of Databricks, maintaining the creating and maintaining the enterprise level data lakehouse, right? So what we can do, we will be having raw data here, okay? Then data engineers will clean the data, right? Clean data will be available, and then this data can be used by AI and ML engineers, right? And also by end users, business users also, right? That is very important thing of Databricks. Okay, fine. Now there are a few concepts I wanted to tell you, but maybe that's fine. There are a few concepts called lake house, lake flow declarative pipelines, and autoloader. But I feel, let me not bombard you with a lot of concepts. Okay, I'll let you know all these concepts maybe in the end. Okay, once we understand all the use cases, or maybe upcoming sessions. Definitely, we are going to learn all of these in details. Okay, that's fine. So the next use case for Databricks is ML, okay, AI, and data science, right? So if you have something to do with machine learning, artificial intelligence, and data science, Databricks has that provision, right? So basically, Databricks machine learnings, it is the special tool to help, I would say, ML engineers or AI or data science engineers that want to build and train their models. Okay, so build and train ML models. You can build and train ML models. See, in this basically Databricks playlist, we're not going to touch upon only the data engineering part of it. I'm going to touch upon all the aspects where we will eventually, once we complete the data engineering part, we will be touching the Gen AI part also. Okay, I think I'm thinking to start Gen AI using Databricks in the same playlist, or we can create this another playlist. But that is also something which is present. Not only data engineering, but Gen AI use cases also you can handle using Databricks. Okay, and you have already understood the ML flow. Using ML flow, we can build end-to-end machine learning pipelines. Okay, there is something called, I think, Databricks runtime for machine learning. What is that? I'll let you know. Okay, but as of now, this is the use case, and I think I have already told you LLM and Gen AI, right? So large language models and Gen AI use cases also you can handle using Databricks. Databricks has integrated like many I think you can connect to many OpenAI models using Databricks. Okay. And Databricks also has, I think, in itself, it has one I think open source model, LLM model that it supports. Okay. I'm yet to explore that, but I think that is also there, right? But and also we can integrate with remaining, I would say, open source AI models also, right? And the fourth use case is SQL analysts, right? SQL analysts. So as I told you, there are analysts and end users that can make use of um, Databricks. They can directly fire their queries. Okay, we don't need any Python or ML code. We can just use SQL to apply the AI on the data. Okay, and this is definitely used by data analyst, SQL analyst. Fifth use case is and business end users. Business and users also can fire their queries if they're aware of SQL. If not, they can use, I think, Genie AI BI is there, which you can tell them your query in natural language, and it will give you the output of based on the data stored in data lake house, right? Okay. And I think there are many other use cases, right? Data warehousing use cases, okay, AI use cases that you can handle. Databricks has got CI/CD support also, CI/CD support as well. Okay, there is something called Databricks bundles, using which you can get the CI/CD support. Okay, basically, in short, Databricks makes it easier to build, manage, and deploy data pipelines. Okay, it makes it easier to build, manage, and deploy ML models. Okay, it can create dashboards. Okay, based on the one source of truth of data, which is data lakehouse. Okay, and it has tool for automation, versioning, and collaboration also. Okay, I think next use case we have already seen, just got introduction, real time and streaming analytics. Real time and streaming analytics. So if there is some data that you want to bring real time to Databricks, yes, that is also available using Apache Spark streaming API. Okay. And structured streaming, I wanted to tell you, it integrates perfectly with Delta Lake, right? And provides basically this streaming pipelines are foundation for lake flow declarative pipelines and autoloader. What is that? I'll let you know. Don't worry. There are many words that you might not be aware. You might be aware. I want to tell you one more thing also. If you already know the Databricks, what is the reason to learn this playlist is you will definitely understand something new in this playlist. Okay, because I'm going to cover each and every aspect. Okay, and the last use case, I think this one, I was very impressed when I got to know Databricks has introduced this one. It is online transactional processing, right? So basically Databricks was lacking the OLTP database, right? If there is some UI which is generating the, I would say, transactional records, right? So what is the, we had to go to some Postgres or some SQL server for that. But now Databricks has got the OLTP database. Okay, it is specialized types of database basically to efficiently handle high volumes of real-time transactional data. Okay, and it is called lake base, right? Lake base. Okay, that is present in Databricks. Okay, and this OLTP database basically enables us to create and manage databases stored in Databricks managed storage, right? So data, underlying data, will be stored in Databricks managed storage. Okay, and you can work with OLTP data also using Databricks, right? Okay, So these are, I think, a lot of use cases. There is a lot of things to learn in Databricks. Okay, I wanted to tell you few things, right? uh, few concepts. Okay, basically, I think I have already told you Databricks. What is difference between plugin Apache Spark and Databricks is Databricks provides us the most updated version. Okay, all the updates we get very fast in Databricks. Okay, now that what we call that, basically there is something called Databricks runtime, right? I'll tell you what is that. So Databricks runtime is the engine. It is the engine that powers your Databricks workspace. That powers the Databricks workspace, right? Now, what is the meaning of powering the Databricks workspace? Basically, it is pre-configured environment. It is, I would say, pre-configured environment. Okay, which includes what? First thing, Apache Spark. Basically, we will need Spark for distributed processing. So this is environment which has Apache Spark libraries. Okay, what libraries? For machine learning, data science, and analytics. Those libraries are pre-configured and enable as part of Databricks runtime, and also optimizations, right? So if you can imagine, in Databricks runtime is like kind of, let's call it a version, right? Where you have pre-configured environment. Okay, it has Apache Spark, data engineering libraries that you need, and also inbuilt optimizations, right? And then I told you something called this runtime for machine learning, right? Databricks runtime for machine learning, right? Databricks runtime for machine learning, which is what? Basically it comes in with built-in, okay, built-in libraries and settings, libraries and settings for ML related work, right? So if you want to use your cluster for ML work, you can select the Databricks runtime. How to select? I'll explain you in upcoming videos, right? So this is what, going ahead, like if you see any Databricks runtime word from me, it is just the pre-configured environment or version. We can call it a version of Databricks that has the package of Spark, few libraries, and few optimizations, right? Okay, and I think the couple of things also I wanted to take you through in the start only, right? Because there are a hell lot of things. I'll tell you. There is something called lake flow declarative pipelines. Okay, though these were, I think, earlier those were named as delta live tables, right? These were called as DLT. Now I think they are renamed it with lake flow declarative pipelines. So you can understand lake flow declarative pipelines. Those are declarative, right? We just declare what we want to do with the data. Let's say you are saying, I want to clean the data, right? And then I want to, I would say, if there is some nulls in the data, I want to fail my pipeline, okay? Or I want to let's say that data is to be passed ahead in the storage, but I want few warnings for that, right? So lake flow declarative pipelines are for that. You just declare what you want to do. Basically, in PySpark, what we do, we write the entire code. In lake flow declarative pipelines, the code is written in the backend. You just specify what you want to do, right? What all use cases. For example, I think, just a second, let me start charging of my laptop. Okay, fine. Now, see, if you, I think you must have heard the um, CDC, right? CDC is there, then you have SCD type 1, SCD type 2, right? In plain PySpark, we write a code for SCD type 1 and SCD type 2. But in case of leg flow declarative pipelines, earlier called as delta live tables, you just specify that you want to process the data with SCD type 1, SCD type 2. It will take care of everything in the backend. Okay. So you just specify what you need, and you just create, I would say, create the notebooks, right? And DLT or leg flow, I will just write DLT will take care of schedule, I would say not scheduling, it will take care of the dependencies. Okay. So for example, let's say you are creating pipeline 1, okay, pipeline 2 and pipeline 3. Now your pipeline 2 is the initial pipeline, okay, then your pipeline 1 is dependent on pipeline 2, or notebook 1 is dependent on notebook 2, and notebook 3 is dependent on notebook 1, right? So delta live tables or leg flow declarative pipelines will automatically decide the dependencies. You don't need to schedule the jobs manually, right? That is basically, it comes with little more cost. If you have some more facilities, the cost will also be more, but that is available in Databricks, right? So if you have less knowledge of coding, that is also fine. You can pay little more price and you can work on the data engineering use cases, right? There is something called auto loader, and this is basically the part of I would say structured streaming. Mostly this is used in structured streaming. Okay, so what it does basically, it is the tool in Databricks. Okay, it is the tool in Databricks which helps, okay, to bring the new data, the new data from cloud storage. Okay, so it automatically identifies the new data, right? It detects new files automatically, right? So why I said it is part of structured streaming is because as soon as your new data comes in, as soon as your new file is getting loaded to your data lake, it will automatically detect that and it will load that file, load the new data, okay, incrementally. Okay, load the new data incrementally. Okay, it takes care of deduplicacy, right? And what, fault tolerance also, right? So this is kind of a revolution, right? Perfect handling of streaming data. Okay, there are n number of concepts, n number of tools that are available in Databricks. Okay, we will learn all of them in details, in depth, like this one. For example, this is the video, I think we started to understand what is Databricks. Okay, I'll give a quick recap. Okay, so we have not stopped just by understanding the official definition. No, we went into depth. We understood why Databricks is unified, right? We understood what are the use cases Databricks is handling. Okay, so what we have learned? We have learned basically the official definition of Databricks. It's unified platform for building, deploying, sharing, maintaining enterprise grade data, analytics and AI solutions at scale. Why at scale? Because it is indefinitely scalable, right? Okay, and why unified? Because we have lakehouse architecture present within Databricks where we can store all type of data, workflows integrated within Databricks. We can schedule pipelines using workflows. We call it a jobs. There is multi-language support in Databricks. Okay, you can code using PySpark. Basically, PySpark is Python. You can say Python, right? So you can code using Python, SQL, Scala, and R. There's unified governance tool, okay, called as Unity Catalog within Databricks, which supports centralized access control, data lineage, and audit logging that helps organization to achieve security and compliance requirements, right? Databricks has managed infrastructure totally from its side. So we just need to focus on the logic we want to develop and not on the infrastructure and DevOps part. It has got AI driven intelligence. We can use Gen AI tools to understand the semantics of our data, and we can use it to optimize the performance. But understand, this is the help we are getting from AI. We should not completely dependent on AI. Okay. Integration with public cloud, it is integrated with all three public clouds, and we can use storage and security part of public clouds, okay, in Databricks, right? Databricks we have seen is contributing to open source community. Also there's something called Delta Lake, which is storage layer, which provides ACID transaction, schema enforcement, and time travel, right? There is something called delta sharing, everything, right? All these things we are going to learn in depth. How to do delta sharing, right? We will be learning that in upcoming videos, right? So delta sharing, using which you can securely share your live data across multiple platforms and different clouds, okay? There is something called ML Flow, which is an open source platform using which we can manage end-to-end machine learning lifecycle. Apache Spark, we all know, we use it for data engineering purpose. Structured streaming, also it has integrated Spark API for processing real-time data, okay, with fault tolerance. And how we achieve that? We achieve that using autoloader. There is something called Red Dash, which is data visualization tool, which helps the end users, right? We can query the data and we can get the insights from the data. Unity catalog, we already have understood its unified solution for managing data access. Data lineage, okay, data lineage and auditing in within Databricks. Everything is within Databricks, okay? Common use cases, we can build enterprise data lake house within Databricks. If we have any ML and data science use cases, we can build and train AI models within Databricks. LLM and Gen AI models also we can train within Databricks. Databricks has got its own open source model, and we can integrate with many OpenAI models, right? We can connect to many OpenAI models. If there is someone who is data analyst, he or she can query the data, okay, and they can do the data analysis, okay, you needed for their job, right? Business end users also can use the data lake house, okay. We are going to learn. There is CI/CD support using, I would say, Databricks asset bundles. I said right. You can do a CI/CD using Databricks asset bundles. There is real time and streaming analytics that is there. OLTP, which is lake based, that is introduced within Databricks, I think newly. Okay, we have learned about Databricks runtime. It is just the package which has Apache Spark, libraries needed for data engineering and optimizations inbuilt. Okay, Databricks runtime for machine learning. It has built-in libraries for ML related work. Lakeflow declarative pipelines we have seen. Like we just need to declare what we want to do, and Databricks Lakehouse declarative pipelines will take care of that. Earlier, it used to be called as Delta Live Tables. Now it is renamed as Lakeflow declarative pipelines. Okay, and autoloader, it will detect the new files that are coming to the data lake or cloud storage automatically, and it will load it to incrementally to our raw, I would say, raw storage, and it will take care of deduplicacy and fault tolerance also, right? These are all the things I think we have learned about Databricks, and now we are ready to go to the next stage where we will start understanding what is data lake house. So in this video we have said about data lake house n number of times, okay. In next video we are going to understand what is data lake house in depth, okay. So this is about Databricks. We have understood what is Databricks, okay. Why Databricks also we have understood. Now I think you will be little more interested to learn about Databricks, okay, understanding the number of use cases it is supporting, right, and understanding how important in today's era to learn Databricks in depth. I'm saying in depth, okay, not only few use cases, right? Automatically, sorry, here automatically. I think there was spelling mistake that I understood. Fine. Okay. Fine. That's all. I think I'll see you in the next video. And if you are liking this, right? If you feel this is useful for new learners also, and those who are already aware of Databricks, because you will get first thing a revision and also few add-on understandings, right, which are newly arrived in Databricks. Okay, fine, that's all from my side. If you feel this is useful, do share with people, right? Give me likes if I deserve. Okay, if I deserve, I'm saying, give me likes, shares and subscribes on YouTube's. Okay, on Udemy, place your reviews, right? That will help me to motivate, right? That will motivate me to bring more and more such in-depth content. Okay, fine, that's all. I'll see you in the next video. Thank you so much.